Now, in this demonstration, and really instead of creating a new project for risk assessment, we'll read a project. Now, we have a project which is ready. Now, in this demonstration, we're using PTA, or Practical Threat Analysis, which is a very simple tool and very nice to use for risk assessment. Now, it's good to use because of its simplicity at first. Now, looks like we have this project, which is actually a sample that comes with this tool. Now, if you don't have any previous experience with risk assessment, you can use this sample to learn about how risk assessment is done and then what to include in your own risk assessment. So let's go ahead and get started right here in this main page of the project. Now, what we have here is a company, which is a financial institution, and it deals with currencies and stock markets and really that kind of stuff. Now, the total value of our company, or the total value of assets, which is technically more accurate really in this assessment, is $1 million and almost another half, so 1.5 million. So the total cost of countermeasures implemented after the risk assessment is 164,000, and the mitigation already invested is 16,500. Now, the difference here between those two numbers is the total cost of countermeasures. All the countermeasures, from firewalls or web application firewalls to any security applications that were already implemented and we're still currently using and invested in mitigation right now, after studying the new threats is about $16,000. Now, here's the system risk status. This is a maximum risk level, which is 40%. The current risk level is 23 and the minimum is 8.8. Now, these numbers indicate that any threat that might put us at a risk of 40% is too high. Our threats put us at a risk of close to 23.2%, which is the current risk. Okay? The minimal risk, which we wish to go down to, is 8% of the total asset value. This is really the ideal place to be. This is a very risky place to be, and then this is where we are right now. Okay, moving on, you see that the tool represents for you and visualizes for us the threats and risks and our analysis. Now, we have here a chart for the threats. If we look at it, T refers to threats, and we can see here the legend for T9 is malicious, the column is forge, and the state's current currency rate. And this is the impact of this threat. So this threat, if this was successful, the impact of it might reach $150,000. This loss, this is our cost if the attack was successful. And we have threat 10, which might cost us between $50,000 and $100,000. Now I can say that this is kind of 70 or 60 or 70,000. And we have the threat 5, which is a denial of service attack that might cost us around 50,000 and so on. So these are the top 5 risks which are threatening our system based on this analysis. Now here's a chart for the history. It's a percentage, right? And here's the analysis history for what are the threats, the countermeasures, and vulnerabilities. Now, if you want to include or wish to see more details, you can. Now, we're going to go to see our assets. So in any risk assessment project, you have your assets, you have your threats, and you have your vulnerabilities. Now, these are the main project entries. And based on these entries, you can really define what are the countermeasures, implementations, and so on. Let's go ahead and take a look on the assets. And A, in this project, A refers to an asset. So we have the confidentiality of an economist person's information. Now, this is really an intangible risk. And threats associated with this asset are threats 1, 4, and 6. Now, if I want to know what these threats are, I'm going to have to go right here to the threats. And we're going to go there in a few minutes. Now, we also have fixed values, 0, because it's not an asset that you can measure with money. It's the confidentiality of personal information. So it really doesn't have a specific value. In case this asset has been compromised, the cost is going to be very high. Now, recurrence value is 15,000, and the annual value is also 15,000. Right? Now, let's say we have another asset here, the availability of daily exchange rate service. So the daily exchange rate service rates, or the daily exchange service rates, count on our assets, on our servers and the state's server, because the company rates are synced with the state rates. So the threats available to those assets are 5 and 7, and the recurrence and annual value is $100,000. Now don't forget, this is just really a sample project. So, right, we have 6 assets. In a real scenario, you're going to typically have a lot more than 6, right? So here's another one, trust of the public in the exchange rate service. So the trust of the people or our client and our company exchange rate service. So this is the link to the reputation, our company's reputation. If the rates were not accurate, the reputation of your company is going to go down, so people will not trust you anymore. This usually affects everything else. Now, the threats associated with this asset are 5, 7, 9, and 10, and the fixed value is $250,000. Why do you think that is? Why is it so high? Because these rates are on our servers, the people or our public or client connects to our servers to see the rates. So the rates are synced with the state rate or the universal rate. But these rates are available through our servers. This is the cost of our servers, and the annual value is the same. Now, here in the percentage of the value from the total value of our company, if our company has a value of $1.5 million, this is close to 17%. Now, a few minutes ago, we just saw that the cost is about $1.4 million. So we have 6 assets stability of the state's economy. Now, this is intangible and linked to also another type of reputation. 2 threats are associated with it, and the value actually is around $1 million, and the annual is often going to be the same. This is the highest asset we have. Now, this is not controlled by us, but it affects our company heavily. All right, now let's see what are these threats, 5, 7, and 2. So we're going to go right here to the threats menu or page, and we start to read. We have threat 1 to 10. We have 10 threats, so a hacker corrupts the database by SQL injection. We have another threat, an insider corrupted database with SQL injection. Looks like we also have another insider that connects the database via the LAN and corrupting and modifying the data. Looks like we also have a denial of service attack against our website. Database corruption with a hacker or by a hacker from the internet, if not by SQL, because we've identified SQL previously in a different way. Now here we have another threat, an HTTP request to get access to OS resources. So it means directory traversal. One of these attacks. Now we have here a malicious economist forging the state's currency rates. This is not an attack directed at us on our systems or our assets, but it affects us because if the state rates have been forged with wrong values, then we'll be affected, and hostile countries might manipulate currency rates by recruiting economists. Really, this is also not a direct attack to our assets or to our facilities, but it affects us highly. All right, so let's go ahead and read what we have here on this threat page. If we look down here, we have tags for each of the threats. So we have probability of occurrence. SQL injection from a hacker has 0.33% probability of happening, and the insider 0.16 for another malicious insider. DOS attacks 0.82. That is higher because DOS attack is easier to happen. SQL might be a little bit hard, but DOS attacks and DDoS attacks are actually easier to make happen and be successful. For threats, 0.6, also 0.82, and so on, is the probability of this attack to be successful and to be initiated as successful. This attack threatens which assets? A1 and A3. And which vulnerability can cause this attack? We have vulnerability 6 that we can check from here. And the mitigation plan or countermeasures, the C refers here to countermeasures. So we have countermeasures to mitigate this attack and the risk. So the threat, that's the current risk in percentage, so it's about 2.3%. Now it's a decimal number here, and the values that are at risk is 34,000, 34 and something. Now, if the attack, which has a 0.33% probability of happening, was initiated and successful, it would threaten 2 assets because of this vulnerability and the value at risk, or the cost or the loss to our company, would be $34,000. Now, we've implemented this mitigation or these countermeasures. Now, the countermeasures can be implemented, or when you're studying countermeasures, it really should not exceed, of course, the value at risk. This is the ROI, return on investment. So if the mitigation will cost you $50,000 and you're protecting an asset which is only $34,000, that doesn't make any sense. You're losing money. You cannot implement such a countermeasure. But if the countermeasures cost $5,000 and you're protecting an asset that's worth $34,000, then that makes a lot of sense. This is a good strategy or a good mitigation. All right, let's go for 2 vulnerabilities and see what are the vulnerabilities that can cause them or that can allow an attack to be successful. So we have one server database and a database that is accessible through the internet. So threats 5 and 6 and countermeasures 1. So you notice here that everything is related together. Assets, threats, and countermeasures are all related together and with the vulnerabilities. Now, web server also, a database or machine accessed via a LAN internal network. We have also countermeasures here, and the small description is always helpful for you to remember what it is, and for whoever is reading this document to know really, what are we talking about here? What are we protecting? Vulnerability 4 and database passwords might be sniffed, so mitigation here is to use encrypted networking, encrypted databases, and so on. So an insider might learn passwords that are transferred in plain text. SQL vulnerabilities in MS Server 2003 and IIS 6 have shortcomings that enable exploitations of the operating system via HTTP protocols. Now, mitigation would be something like updating to a newer version or stopping some services that are allowing this vulnerability and so on. So, looks like we have a total of 13 vulnerabilities. Now, let's talk about what are the countermeasures implemented for such vulnerabilities. Firewall. And install a firewall. Now, that looks like it's already implemented. Yes, it's a hardware firewall. So which vulnerabilities are we mitigating here? Only vulnerability 1. Now, vulnerability 1 allows 2 types of attacks or threats, which are threat 5 and threat 6. So we're actually now mitigating 2 threats. Now, the cost of this mitigation of this hardware firewall is $3,500. A recurring cost of $1,000 might be a subscription to keep the firewall database up to date. Firewall has signatures to detect anomalies, and the annual cost would be $4,500. Why? Well, because we can calculate it this way: the fixed cost as $3,500 plus the recurring cost of $1,000. So now you go in and you're gonna define the annual cost on the first year as $4,500. But if you're studying here, we can create another section or another column. And if you're studying here, the annual cost of this firewall, not only for the first year, which includes the price of the firewall, will be a different formula. The annual cost would be the subscription. So let's say that you're subscribing to the vendor to keep your database up to date and maintenance, maybe a salary for an administrator for this firewall. So all of these could be really included together in the annual cost. Now, it actually depends on how much you want to be specific in these columns and this cost. Countermeasure 2, physically protect access to local network wiring to the data center room, to switches and router closets. So this is some kind of prepared room to have all of your network devices and hardware and protection devices and servers all in one room. Now, the cost of implementing this room is going to be about $14,000. Annual cost will be $7,000. So let's say you need to add things like keep it cool in there, so you need to add air conditioning to that room. You need maintenance for the fire extinguisher and this kind of stuff. Enforce quality passwords. So this is a kind of policy, right? So now we see that there is no fixed cost. Why? Well, that's because you're not buying anything here. It's just a policy. Now the reoccurrence cost and the annual cost is $1,000, but it could be here the salary of an administrator handling this kind of stuff. Now, of course, there's no one that that we could get to work for $1,000 annually. If we could, great, we'd all be out there hiring them. But keep in mind that we're really just talking. We're just kind of throwing some examples out here. The numbers are really not real, right? Let's go ahead and proceed through these countermeasures. So we have 20 countermeasures. So we're going to move to another page, which is the attacker type. Now, the attacker type could be a web user, anyone on the internet, an insider, an employee, a hacker from the internet, an economist, or a competitor or state enemy. Now we see that profile and motivation are not filled in these columns, in these fields. Now, of course, I would prefer, and your managers would prefer, to have these filled, but motivation for the web user might be a mistake. Now, you can fill it here. It might be by mistake causing some issue, or intentionally because he wants some money or he wants to harm your company and so on. That might be the motivation. Motivation for the hacker may be paid by your competitor, or some other reason might be his motivation. Now, the tools available, or the way they can access your system, is definitely from the internet or from the LAN. So these are really going to be the only two ways to get into your system. Now, here are the entry points defined. Now, what are the available entry points? The rate page on the web application, right? So from the internet or from the public. The Economist desktop application for updating the rates, which is it's apparently an application to update the currency rates available to economists only. Could be a computer machine on the LAN inside your network. Maybe a database server can be accessed if I have a direct connection to it, or a console connection. But mainly the database server will be accessed through the internet by SQL injection, or internally also by SQL injection. So we have now the attacker type. We know the attacker type, and we know the entries. So now your focus is going to be to close these entries. Now, we cannot close them, but with the countermeasures, we can define regulations to filter the connections coming into our systems. Now, it looks like we have tags, if you wish, and documents for helping. Now, you can see how risk assessment is really easy to read, but it's very hard to create. The risk assessment would need a full vulnerability study. We'll need real cooperation from all the teams to find the values of each assessment and each asset, the cost in case an attack was successful, the cost of mitigation, the return of investment for each mitigation or each countermeasure. There's plenty of documents that are going to need to be created before you get to this point. This is not a project that you need to just spend one day on, or a week, or even a month. It's a pretty long project that's going to need quite a bit of cooperation and help from some other professional people in your organization to achieve it.